Hello, is anyone there?
Yes, good morning. Welcome.
Hi, is that Kurt?
No, you're speaking with Jonathan. I'm your Zoom operator for the morning.
Oh, great. Thanks, Jonathan.
Cool. So what I will do is manage everyone's mutes and asking them to activate the video when their time comes, but you're obviously welcome to interject at any point.
Sorry, I just turned my volume up. Say that again.
Sorry, I said I will prompt people to mute and unmute as necessary, but you're
Right.
welcome to interject at any point.
Okay. So the only people on the Zoom will be myself and the speaker and you. Is that right?
That is correct, yes. So it's only yourself, those presenting, and me.
Right. And then the rest of the participants are on the normal platform viewing it.
That's correct. Yeah. The rest of the participants are on the on-air platform,
Yes.
and then their questions will be relayed to you via Slack channel.
Okay, great. So the Q&As, I've got the Slack channel open here, and the moderator, Komotsu, I think, we'll put them on the message box, the Q&As, right?
That's correct, yeah.
Yeah, great. Then I think we're set. Just one technical thing. I put it in the chat yesterday, and I notice it now that the audio has this sort of, I describe it as a dropout, but it's just like it's noise sometimes. I don't know if you guys have detected this. Other people have mentioned it as well. Sorry?
So I'm just speaking to one of my colleagues quickly to see if he's aware of the issue.
It's not like majorly disastrous in the sense that it suddenly stops and you can't hear anyone. It sometimes buffers, but that's fairly rare. It's just a little bit of like a, when someone's speaking, there's just a bit of a, frequent little sort of, it's like noise, like crackling,
Yes. So we haven't noticed anything beyond the usual sort of Zoom has noise cancellation stuff that it does. Yes. So something so often it'll drop the level to try and deal with something.
Okay.
So we haven't noticed anything beyond that.
Yeah, it's funny now that you're speaking, it's not happening at all. But when you first started speaking, it was like a game, like it was yesterday.
Okay.
Anyway, I don't think it's a major thing, and yeah.
Okay, perfect.
Great. Okay, well, I'll just hang in here till 9:30 when it all begins.
Great. Thank you so much.
Okay, thanks for your help.
Good morning, David.
Hi, Vanessa. How are you?
Good, thanks. How are you?
Good. All sorted?
I think so. Should we check the screen sharing or?
Yeah, you want to go ahead with that?
Yeah.
I guess the other speakers will be joining supposedly as well, won't they?
I hope so.
I hope so, yeah. I saw one of them only got the link, so.
So, David, are you seeing the
I'm
presenter?
seeing your presentation. Yeah, that's
okay. You're not seeing the presenter notes or anything.
No, I'm just seeing the presentation. Yeah.
Great.
Excellent. So you know it's nominally a 13-minute talk with 2-minute questions.
Yeah. Are you going to wave at me somehow?
Yeah, maybe I'll do this. The Winston Churchill salute.
Cool. I'll keep an eye on the time though.
Yeah. So the moderator, it's Jonathan, isn't it? The moderator?
That's correct.
Jonathan, will the other speakers join this Zoom sort of just before, nominally just before they're due to talk? Is that right?
The idea is that they should all join before the start, but they are able to join once we start.
Okay.
And then, as I'm sure you're aware, Elizabeth has sent a pre-recorded presentation, but will probably or may join for Q&A thereafter.
Okay, okay. I wasn't aware of that actually. So you handle the pre-recorded presentation, correct?
That's correct, yes.
Yeah. So I don't have to do anything other than introduce her.
Yeah. So once you introduce, I will then play her presentation
Great.
out.
Good. Thanks. Vanessa, do you know how you pronounce Elizabeth's name? Nalamansa, is it?
I think that's correct.
Good. I'm doing this from my office, which is like, I'm starting to come back to it very infrequently.
Thank you for joining us again today. So the first session will start at 9:30, so that's in 3 minutes time. Also note that today our first parallel sessions will start after the first session. Thank you.
Hi, Lena. How are you? Oops.
Hi, David.
Can you hear me? Good.
Yes, yes, I can. How are you? Nice to meet you.
Nice to meet you as well. I'm glad you got the links and everything
Yes,
working.
Everything is working perfectly.
Great. And you have, you're going to be presenting your presentation live, right?
Mm-hmm.
Yeah, with sharing.
Yes.
Yeah. And you know that normally you have a 13 minutes to speak and 2 minutes for questions.
Yes. Yes,
So
of
I'll
course.
put my fingers up like this to
Okay.
indicate 2 minutes to go.
Okay, I will. And please, if you notice that I miss it, please feel free to interrupt or telling me 2 minutes.
I'll start doing this.
I can share my screen, right?
Yes.
My presentation.
Yes,
okay.
of course. Yes.
Okay, perfect.
And to pronounce your name, is it Lena Canas?
Lena Canas.
Canash.
Canas.
Canash.
It's fine. Don't worry. Don't worry. It's totally fine. It's perfect.
I'll just say Lena.
You can you can say Canas. Canas
Right.
is perfect.
Yes. And you're based at the IAU office in Japan, right?
Yes,
Yeah.
the IAU Office for Astronomy.
Right.
Outreach, yes.
So we've got 1 minute to go according to my computer clock.
Yes.
Okay, I guess we can start. I'd like to welcome you all to the second day of the African Astronomical Society meeting. This first plenary session, there will be 4 talks, 2 on science, followed by 2 on education and outreach. So the first speaker today is Vanessa McBride, and Vanessa is going to be talking about the neutron star population of the Magellanic Clouds. Over to you, Vanessa.
Hi, everyone. Is that working all right?
Yeah, can see it.
Great.
Page 2, I think.
Oh, yes. Okay, so I'm going to chat to you today about the neutron star binary populations in the Magellanic Clouds. And this is work I've done with a number of collaborators. You can see all of them listed here. In fact, David is one of them. And a lot of the work that's been done here has been done as part of Naomi Titus's PhD. So I'll give a quick motivation for why we're interested in neutron star populations in the Magellanic Clouds. And then I'll also talk a bit about X-ray binaries, focusing on the small Magellanic Cloud, and then link to the population of radio pulsars and how they fit together, and then chat a bit about some of the future challenges. So the Magellanic Clouds are a great place to study star formation and evolution because it's a bit simpler. All the stars are at the same distance. It's out of the plane of the galaxy, so you're not stuck with a lot of interstellar obscuration. And of course, the line of sight to most of the stars is pretty much the same, so there's also not variable absorption along the sight lines. And while you can study the stellar populations with a couple of snapshots, the galaxies are near enough that individual stars are still resolved. And they allow us to probe regions of quite different environmental properties, so differences in star formation and metallicity. And of course, one of the key things, at least for this work, is that there's a statistically significant number of massive X-ray binaries in the Magellanic Clouds. There's about between 100 and 150, although we've only got 1 gamma ray binary in the large Magellanic Cloud, and a much smaller number of radio pulsars. So in the small Magellanic Cloud, only about 7 up until now, and around 20 to 30 in the large Magellanic Cloud. So massive X-ray binaries, I think you had the introduction to this probably as part of Ishamaling's talk yesterday afternoon. And these are stars where you have a massive main sequence star, or sometimes a supergiant, transferring mass onto a compact object. And that could be a neutron star or a black hole. And we're interested in these massive X-ray binaries for a number of reasons. One of them is that it's in massive stars where we synthesize the heavy elements. And in fact, a lot of the dynamics of massive stars, such as supernova explosions that distribute these heavy elements throughout the galaxy for new generations of star formation. Also, massive stars, it turns out, the large majority of them occur in binaries or with some degree of multiplicity. And this binarity influences the evolution quite significantly, especially when you've got mass transfer between the two components of the binary. So that's another key reason to look at understanding massive stars in binaries. And of course, the remnants of these stars are very interesting objects. So once these stars go supernova, they leave behind either a neutron star or a black hole. And these are key laboratories for exploring some very exotic physics. So how matter behaves at extremes of gravitational potential, at extremes of magnetic field, temperature, and pressure. And it's these progenitors, these massive binaries, that can eventually evolve into things like double neutron star systems, which are, of course, potential gravitational wave sources. So with that motivation, let me move on to talking a bit about the population of X-ray binaries in the Small Magellanic Cloud. This is a picture of the Small Magellanic Cloud in neutral hydrogen from Stanimirovic. And it shows the distribution, all these little blue circles of BE X-ray binaries, massive binaries around the cloud. You can see that they mostly follow the regions of high gas density and high stellar density. And there are a significant number of these objects. In this catalog, there are about 148 objects. Those include confirmed BE X-ray binaries and some candidates. So just to be clear on what I mean by BE X-ray binaries, you can have a bunch of different types of massive X-ray binaries, and they're kind of separated by the type of mass transfer that happens in the system. So you can see on the top left, this is a picture that shows a wind accretion, which could be smooth or clumpy. Then you also get accretion from the massive star via Roche-Loeb overflow, which you can see on the top right. And then you get sort of a combination effect here at the bottom, which is where even the massive star, the main sequence B-type star, is rapidly spinning and has a disk of material around its equator. And then in those cases, accretion happens from that disk of material. And these are just the numbers in the Small Magellanic Cloud. So we actually have no clearly detected wind accretors. We've got one system that shows Roche-Loeb overflow, and we have over 100 of these BE X-ray binaries. These are the ones where we get the mass transfer through this circumstellar disk around the early type star. And what's quite interesting, I think, about these populations is if you make the comparison between the Small Magellanic Cloud and the Milky Way, you know, the mass of the Small Magellanic Cloud is only about 1/50th of the mass of the Milky Way, yet we have very similar numbers, around 100 BE X-ray binaries in the Small Magellanic Cloud, and the same order of magnitude in the galaxy. And we think that this is because of the star-forming history of the Small Magellanic Cloud. The plot at the bottom here, these two plots, show the luminosity functions of massive X-ray binaries for a number of nearby galaxies. The one on the left is just showing for quite a range of nearby galaxies. And so this is showing the number of objects above a certain luminosity as a function of luminosity. And when you correct for star formation rate, you can see that these luminosity functions lie very closely on top of each other. So it's a strong reason to believe that the star formation history and the active star formation is the reason for the large number of these B X-ray binaries in the Small Magellanic Cloud. So there have been a number of ways of estimating the star formation history. A lot of work using color magnitude diagrams has been done by Harris and Zaritsky. This is really a crude sketch that I made using some of the fields that Antonio studied. So these were specific fields in the Small Magellanic Cloud that looked at star formation in regions where there are lots of B X-ray binaries. And so she found that 42 megayears in the past, there was a rather large peak of star formation. And that is probably what's given rise to this large population of B X-ray binaries. So going from that background and now making the link with radio pulsars, there's a potential evolutionary connection between radio pulsars and binaries and these B X-ray binaries. So if you sort of look at the evolution of a neutron star, this is the age in years here, this is its spin period evolution. It starts its life as a radio pulsar, spinning rapidly and losing energy through its relativistic pulsar wind. And then at some point, possibly going through a gamma ray binary phase, it ends up here around an equilibrium spin. And this is where we see these objects as B X-ray binaries. And then in the future, it may go on to form a gravitational wave source. And so this is work that Naomi undertook as part of her PhD thesis, which was to look at reproducing the current population of radio pulsars in the Small Magellanic Cloud, and also to predict what MeerKAT may see in the surveys that are coming up of the SMC. So when she started this work, only 5 radio pulsars were known. She discovered another 2 of these. But the main part of her work that I'll talk about is the work that we've done on the population synthesis. And so in order to estimate these populations, she used a population synthesis model called SIBA. And of course, these models take loads of different parameters. I'm not going to go through all of these. You can look them up if you like, but there's a lot of input parameters that go on here. And they evolve both single and binary stars using analytical approximations to things like the stellar evolution tracks, also taking into account things like wind accretion, tidal interactions, angular momentum losses, and various other types of interactions that these binaries can have. So in the simulation, we actually started off with something like 3 million binaries and no single stars at all. And we used this recipe from Antonio to model the star formation history, because this tells you when to inject most of these stars on the 0H main sequence. And what's interesting about this is that it's quite a high level of star formation that's injected, but the other models which show slower or more sustained star formation actually just don't work to reproduce the observed populations. So you start off these binaries, you evolve them, and then after some time you need to go and select which are the radio pulsars. And so we do this based on the period and the period derivative, which is shown in that plot. And then to try and estimate what the radio luminosity is, Naomi applied some empirical formulas, including a beaming fraction. And these are the results. These plots look terribly complicated, but I'll just walk through them. On the left, what we can see is the pulsars, radio pulsars in binaries. And on the right, you can see ones that are isolated. So those are ones where actually the binary has been disrupted during the supernova explosion. What you can see at the bottom is the number of pulsars as a function of period. You can see most of the objects, actually you probably can't see because the isolated pulsars, the scale goes up to about 1600, and with those in binaries, only about 60. So you can see that most systems got disrupted, but that you end up with a large distribution peaking around a period of about 10 seconds. But on the top plot, it's showing the radio flux as a function of period. And what you can see there is that the shorter period systems are the brighter ones. And the longer period system, the flux is almost off the bottom of the plot. So you just can't see those objects. And on top of those, you can see the 5 or 7 radio pulsars that are known in the Small Magellanic Cloud. So you can see a large population, but we know that we can only see the fast spinning of these because those are likely the brightest. So finally, just to say that Naomi's results, predicted something like 16,000 radio pulsars, and in fact agreed very well with the previous surveys. So for the Manchester survey, they detected 5 radio pulsars in the Small Magellanic Cloud. And when she simulates the condition of that survey, then she ends up with 4 plus or minus 1. So that's very interesting. She's also predicted about 20 pulsars for future MeerKAT surveys of the Small Magellanic Clouds. And these may be things, turn up in the upcoming TRAPPIST survey. So just to say that we hope to bring these 2 populations together in the future. So to use this massive X-ray binaries as a constraint on some of these population synthesis models. But in order to do that, we have to fine-tune the recipes for mass transfer that happen in these BE X-ray binaries. Thanks, David.
Thanks very much, Vanessa. I don't see any questions on the Q&A yet, but I have one for you, or maybe it's more one to Naomi, actually. You mentioned earlier on the fact that there's a big difference between the radio pulsar population in the LMC and the SMC. And of course, we know that the two are very different in the way star formation has happened there. But do you know if a similar population simulation might be done in the LMC? Is Naomi interested in that, or do you know if there's people doing that sort of work?
Yeah, I think Naomi's trying to run a similar simulation for the LMC. It is quite interesting because it doesn't seem to be as highly star forming as the SMC, yet it is somewhat closer. So it's 50 kiloparsecs as opposed to 65 for the SMC. So it will be interesting to see if the large number, the slightly more dominant number of pulsars in the Large Magellanic Cloud, is just an observational effect due to those things, or if it's actually related to the star formation at all. Okay, so there's one other question that's just come in. Nice talk, Vanessa. Could the low BE population not also be due to a selection effect, since these objects lie deep in the galactic plane and may well not be visible to us except their strong X-ray or radio? I should maybe moderate that question, because they're not in the galaxy, they're in the Magellanic Clouds. Yeah,
sorry,
but maybe
Renee,
they mean the galactic population. Or...
Yeah, she's talking about the galactic population, I suppose, yes.
Yeah.
That was from Renee, by the way.
I think that there is an option that we've missed a whole bunch of them because of the strong absorption, although there have been lots of surveys of the galactic plane with things like integral, and those have turned up a whole new class of some of these systems, highly obscured X-ray binaries. And so we have found some of them like that, but it will be interesting to estimate how many more could be lurking in that stuff.
Yeah, I mean, integral is great because it's so much harder, so it can look through the absorption better. Okay, I think we better move on. Thanks, Vanessa.
Thank you.
So the next talk is from Elizabeth Nalamunsa, who's going to be talking about H1 scaling relations in WISE-WISP galaxies. So over to you, Elizabeth, and you should be able to share your presentation. Well, actually, your presentation is pre-recorded, right?
Hello everyone, my name is Elizabeth Nalumisa and I'm from Chambogo University in Uganda. I'm going to present about a paper we recently published with my co-investigators on global scaling relations of H1 in a sample of WISP galaxies for which we also had WISE data. Our work is on star formation in nearby galaxies. The image you see on the right is an image of a star forming region in the Orion Nebula. So our star formation is basically the oil for the wheels of the gas cycle, which involves accretion of gas, consumption of gas, and its eventual expulsion into the interstellar medium. The star formation actually leads to the consumption of this gas, and it also leads to the production of heavy elements and the enrichment of the interstellar medium with these heavy elements. Hence, star formation is a crucial process in galaxy evolution. We specifically look at stability thresholds for star formation in nearby galaxies. We study the gravitational stability models of these galaxies to predict where stars should be forming or where we can expect stars to be forming, and we compare these to observations of star forming regions in galaxies in order to find out other stars forming where we expect them to be forming, and wherever they are forming, what are the apparent thresholds for the onset of the star formation. Our paper that we just published is a data paper. So we present the data that we used, the reduction steps that we followed, and some scaling relations that we studied in order to find out whether our data were behaving the way they are expected to behave according to the literature. So this is a screenshot of the abstract for the paper. It's available on the archive as well as on the monthly notices of the Royal Astronomical of the Royal Astronomical Society website. My co-investigators were Dr. Ed Elson and Professor Tom Jarrett. So we used H1 data from the WISP survey, which was done on the Westerbork telescope, image on the right. For more information on the WISP survey, you can read the papers below. We also used infrared data from the WISE survey, and we specifically used the 3.4 micron data and the 11.6 micron data. The 3.4 and 11.6 micron bands trace the stellar disk and the star forming disk respectively. You can read more about the WISE survey from Wright et al. 2010. We used the catalog. We obtained infrared data for our work from the extended source catalog of Jarrett et al. 2019. The extended source catalog enhances the resolution of the point source catalog, which was the original output catalog by the WISE survey. And by enhancing the resolution, it's able to resolve extended sources such as galaxies. This is an example of a galaxy in the extended source catalog, and on the left, we have the 3.4 micron image, which traces the stellar disk, whereas on the right, we have the 11.6 micron image, which traces the star forming regions. We have a sample of 228 galaxies spanning from lenticulars to early type spirals, intermediately type spirals, and dwarfs. And the majority of our sample is nearby and lies within 40 megaparsec. To prepare our data for analysis, the pipeline of Jarrett et al. 2019 outputs photometry and also gives us derived quantities like stellar masses and star formation rates using the empirical relations of Kluver et al. 2014. We got H1 data from the public database of the WISP survey, and we downloaded the 30 arcsecond resolution cubes. We applied sigma clipping to them, which gets rid of the diffuse noise. And for robust noise rejection, for example, getting rid of the noise peaks that survive the sigma clipping, we took an extra criterion adapted from Nodamer et al. 2005. This is how it works. What you see here are examples of line profiles from different RA deck positions in a given data cube. The black profiles are the profiles we take out of the cube before sigma clipping. The blue profile shows the peaks that remain, or rather that survive the sigma clipping. Whereas the red profile shows the profile that we are left with after the extra criterion of removing the extra peaks that survive the sigma clipping. So, for more information, for details of this method, you can go to the method chapter of our paper. We obtained H1 data products, which included H1 intensity maps, velocity fields, velocity dispersion maps. For these maps, we used Gauss-Hamite polynomials fitted to the line profiles. We did not use moments. And we also have radial profiles of the mass surface density, as well as global profiles for the flux density. These data products are available on request. We also have tables of measured products, of measured quantities, sorry. We have systemic velocities, corrected line widths, total fluxes, H1 diameters, and masses. And these tables are available in the online version of the paper. So to look at the scaling relations in our sample, we looked at enclosed quantities. What do I mean by this? For example, if we were to measure the H1 mass to compare with the stellar mass, we did not measure H1 mass in the entire H1 disk. Rather, we measured the H1 mass that is enclosed within the stellar disk so that we could compare spatially collocated quantities. And we defined the stellar disk by an isophoto at the 1 sigma level in the 3.4 micron image. And these usually lay around a surface brightness of 23 magnitude per square arcsecond, as in Vega units. We looked at several scaling relations. We looked at the mass luminosity relation, for example, and what you see here is in the top panels is the H1 mass plotted on the y-axis against the stellar luminosity. That's the 3.4 micron luminosity in form of the absolute magnitude. That's on the left, and on the right we have disk surface brightness. In the lower panels we have a mass to light ratio plotted against the same x-axis. The mass to light ratio I'm referring to here is the H1 mass versus the 3.4 micron luminosity of the galaxies. The plots are color coded according to morphology, such that the reds represent lenticulars and dwarf spheroids. The green represents the early type spirals. Cyan represents intermediate, blue represents late type spirals, and while the gray represents the dwarfs. And we can see already that our data are behaving as we expect according to the literature. We see that in the top panels, the early type spirals, which are brighter in magnitude, in absolute magnitude, and in surface brightness, they have more H1 mass than the later type, the later type galaxies. Whereas in the lower panels, we see that the later type galaxies are actually more gas rich than the earlier type galaxies, in spite of having lower H1 masses. And this is because their small stellar disks contain higher relative H1 masses compared to the earlier type spirals. We also looked at the star forming main sequence, which is a plot of the star formation rate against the stellar mass. That's the y-axis here versus the x-axis. The star forming main sequence is a tale of star formation histories, as it compares the ongoing star formation with past star formation, which is in the form of the assembled stellar disk. The plot here is color coded according to the W2, W3 color index. This color index is a this color index indicates dust content such that the higher values or the redder values indicate higher dust content, while the bluer values indicate lower dust content. And this is also a tracer of star formation rate, such that if I zoom in and you look at any given stellar mass, the galaxies with higher dust content will always having higher star formation rates than the galaxies with lower dust content. So the black solid line here is the fitted relation, which is shown in this equation here, our fitted relation for our sample. And we can see that the high dust content galaxies, which are also the higher star forming galaxies, are generally above the star forming main sequence, whereas the low star forming galaxies are below the star forming main sequence. Our relation also traces the migration of high mass galaxies away from the star forming main sequence, if you can see where I placed the cursor here. And this is due to the passive evolution of these galaxies after they have finished assembling their stellar disks. So they are no longer actively forming stars, and they're beginning to migrate off the star forming main sequence. So, and there are several things that, or factors that lead to that. You can read more about that in the paper for the sake of time. We also plot the Kluver et al. 2020 and Prakash et al. 2018 relations, which have shallower slopes, but this is also in agreement with the literature because their samples are high mass samples, and as Kluver et al. 2020 discussed, that the main sequence is sensitive to the kind of sample that you use, such that high mass samples tend to have shallower slopes, and that is partly contributed to by the migration of the high mass galaxies away from the main sequence and the varied star formation histories in that part of the in the high mass range. So we looked at several scaling relations, but because of time, I can only discuss those two. However, you can have a look at our paper, Nalumisa et al. Nalumisa et al. 2021. It's available on the archive. We have H1 data products that are available on request, so give us a shout if you need these data products and have a look at the different scaling relations that we studied. That's all from me, and thanks for listening. Have a good day. God bless.
Thanks very much, Elizabeth. If we we have time for just a couple of questions. So I'm just looking in the Q&A chat. I don't see anything at the moment. I'll just wait a moment to see it if it gets updated. Okay, look, I think there's no questions. Thanks for a very clear talk, and we'll proceed now with the next speaker. We've finished the first two science presentations for this plenary, and now we're on to the education and outreach talks, and they're both from IAU offices. So the first one is from Lena Canas from the IAU Office for Astronomy Outreach. And I'll hand it over to you, Lena.
Thanks, David. I'm not sure if you can hear me.
Yes.
Thank you so much. I'm going to share my screen. I'm sure now you all can see it. So as you mentioned, David, my name is Lena Canas, and I work for the IAU Office for Astronomy Outreach. We are based at the National Astronomical Observatory of Japan in Tokyo. And I wanted, first of all, to thank the organization for having me here today live, which sometimes it's not possible due to all the constraints in time zones. And I'm really excited to be here and appreciated to have this time to share some of the programs that our office carries. I wanted to start to give a little bit of a background on the IAU and how our office inserts in the IAU structure. So the IAU is the largest association of professional astronomers, and we are over 12,000 professional astronomers across 100 countries. The mission of the IAU is to promote and safeguard the science of astronomy through research, communication, education and development with a specific focus on international collaboration. And this is this international cooperation, not competition, is at the very core of all the actions that and programs that we try to implement. In 2018, the IAU launched the new strategic plan for 2020 until 2030, and with the different goals our office aligns in particular with the IAU engaging with the public in astronomy through access to astronomical information and communication of the science of astronomy. So we particularly focus on two keywords across our programs: access and communication. Of course, the IAU has other offices aside from their central scientific bodies, which is the Office for Education, Young Astronomers, Astronomy for Development, and our own that is focused on outreach, communication, and public engagement. The focus of our actions are mostly on the outreach of the IAU itself through mailing lists, social media, trying to reach out the wider public and also IAU's members through across different platforms and channels. One particular focus of our office and our actions is to support skill building for astronomy outreach professionals. We do this through the publication of peer-reviewed journal, supporting science communication conferences, and also running communication training for professional astronomers and outreach professionals. One of our main actions is also to coordinate international networks related to our projects and of course focus on outreach professionals around the world. Our team is very small, and I stand here today in representation of the office, but of course I'm not alone. So I wanted to highlight some of my colleagues that although our core team is only 2 people, myself and my colleague Izumi, we are surrounded by at NLJ, and not only at NLJ, by a great team of professionals that also support the implementation aspect of our programs. And not only the core team, but also the IAU National Outreach Coordinators. There are the IAU Outreach Representatives, at the national level, at the regional level, in some cases, that are spread around the world. So their task is to implement and disseminate the IAU outreach activities in their communities, and also to bridge our office and the IAU outreach activities with the local communities related to astronomy. We are present in 136 countries and regions, and the focus of this network, or the interaction, or the way we bridge and link with this outreach professional, it's only at a voluntary basis. So these are dedicated, enthusiastic, knowledgeable professionals that disseminate IAU outreach actions across the world. To give some examples that I mentioned previously of the kind of publications or the kind of activities that we do related to the skill building for astronomy outreach professionals, I wanted to highlight the Communicating Astronomy with the Public journal, which is a free peer-reviewed journal, both online and in print, that is accessible and free for the community. And also the Communicating Astronomy with the Public conference that we co-organize with our colleagues from Commission C2, which is a body of the IAU within the IAU scientific structure. So we co-organize this conference. The next one will be in a fully virtual format from 24 to 27 of May. And I take this opportunity to invite you all to join and to present your work if you're related to communication of astronomy, if you're related to outreach, public engagement, please share your work with the community. It's really important for us to have a good representative participants, and our community, because it's very diverse. It's also important to take these opportunities to share the different work across all communities. As an example of our outreach global projects, this year in particular, we will have 4 global projects. We will focus our actions across dark and quiet skies awareness, which will be highlighted throughout the month of May in celebration of the International Day of Light, which will be on May 16. Usually we don't focus on a particular date, but around a special event, if we can say it like this. We also have a project which is Telescopes for All, in which we and our partners distribute telescopes and resources, but in this case is particular focus on telescopes to underserved and underprivileged communities. And we will have 2 calls for proposals this year, in May, June, and also in September. So I want to take this opportunity again to ask if you are interested in share with us how would you use a telescope to engage your community, and this is a good chance that you can receive a telescope to use in your activities. Another action that we will have later in the year will be in October from 1 to 4, which is the 100 hours of astronomy, in which we celebrate astronomy related events around the world for 100 hours non-stop. Just recently, we finished, yesterday actually, we had the global project on women and girls in astronomy, which runs across February and until March 8. Many of our projects are focused or in and around, as I mentioned, around the date, but we try to identify some projects that we think that should be at the core or transversal to all outreach initiatives that we endorse and support. And women and girls in astronomy should not be celebrated only in 1 month or in a particular date. It should be a baseline across all our outreach actions. That's why we identified a series of programs that we implement not only as a project, a single time event in the year, but that are transversal to, or should be transversal to all initiatives. And it's mostly focused on access and accessibility of resources and accessibility of or translations. So one of them is as I mentioned, the Women and Girls in Astronomy. We provide know-how and we provide support, tailored support to these programs. Another one more focused on people with disabilities. We identified that a lot of people in our community, they struggle to find proper support to implement their activities from an accessibility point of view. The IAU within its structure has the Astronomy for Equity and Inclusion Working Group. So we do have the know-how, we do have the group of people that can provide this support. So we try to bridge our community of professional outreach professionals and the scientific body within the IAU that can provide the support. Another program that I mentioned is based on translation network, in which we match translation needs, resources in need of translation, with volunteers that are willing to translate, make the scientific review and the proofreading of those materials. The most recent project that we have is the Meet the IAU Astronomers, in which we have a pool of nearly 200 astronomers, professional astronomers, that are willing to participate and join meetups, talks with students, parents, and the general public to talk about astronomy, any particular topic, or in any particular language. I want to thank everyone again for giving me this time to be here and to share with you some of our programs. And I want to say that our programs, they're not built within our team. These are programs that are built with the feedback from the community and the needs that the community feels that on how we could support. So this is a program these are programs that are built by the community. So I strongly encourage you to reach out to us. We are in Japan, but actually we are just one email away. So we do encourage you to reach out to us and share with us your struggles, the needs that you have in your programs, and in a way that we can collaborate and support with our future programs. Soon, we will open an additional program that is the IAU Visitors, IAU Outreach Visitors Program, which currently we have it in a hybrid mode. Anyone interested can collaborate in our programs remotely, and then we invite them to come to Japan when conditions permit and stay with us for 1 month. So if you are interested, I strongly encourage you to join us, and of course to reach out to us at any time. Thank you so much.
Thanks very much, Lena. That was great. Yeah, I was just going to ask a question about how has COVID affected your activities, and what do you see the way forward?
COVID, unfortunately, affected our community. Is very diverse. So different countries, different regions were affected inevitably in different ways. Not only the face-to-face gatherings, observing sessions, which is sometimes the most inspirational and most engaging aspect of our activities. Of course, that had to stop. But our community responded in a very quick way, which was quite inspiring to see the way most of our outreach professionals adapt, switching to online observations and sharing online what they were observing. Of course, this is always as good as our internet connection is, how many resources we have, digital cameras, access to telescopes, how much your community has a good access to internet. So in that sense, it depends a lot. From our side, what we tried to do was to I mentioned the Telescopes for All program. For instance, our partners and us quickly tried to add a digital camera to the kit, the telescope kit, to support our community that will receive the telescope, so that they can adapt, at least during COVID, to a digital format. And on top of COVID, we will face an economic serious situation in times to come. So that it's not only about COVID and the current health situation, is what we are facing ahead with economical impact. Okay. So this is what we need to address as a community, and that's why I focus so much my final appeal, yes, if I can say it like this: reach out to us, because we build our support based on the needs of the community, and this can only be done through feedback.
Right. There's one question from Bonnie Thurber saying, what kinds of telescopes do you have? I'm currently working with many teachers in Nepal and now Uganda. Both groups need access to telescopes.
Sorry, I missed the last part of the question.
So Bonnie is saying that she's working with groups of teachers in Nepal and Uganda, and both groups need access to telescopes. So what kind of telescopes do you provide?
We don't focus on a particular type of telescopes. We do focus, from our point of view, from our strategy, if we can say it like this, is to focus on the partnerships. So we do reach to interested companies and say, we have a community, we have a set of projects and programs in different areas of the world. Can you support us? What can you provide to us? And then, based on the different needs of the community, we identified or distribute the best or make the best match. So it's not focused on so much of the kind of telescope, but what is the what kind of partnerships and what is the interest of companies and institutions to support this kind of programs, focused only or mostly on underserved and underrepresented communities.
Right. So I'd suggest Bonnie contact you directly and you can take this.
I know Bonnie very, very well, so please.
Okay, I think we better move on. We're about 5 minutes behind time. So the next speaker is Marcus.
Thank you.
Purcell. And Marcus is also from an IAU office, the Office for Astronomy for Education. So over to you, Marcus.
Okay. Sharing my screen now.
Yes, see that.
Good. All right, so hello and thank you to the organizers for inviting me. My name is Marcus Pösse and I'm director of the IAU Office of Astronomy for Education. So given the talks that you've already heard and the talks that are still coming up, I think it's quite logical for you to ask, oh God, not yet another institution. So what does this one do? So, and it is true that there's a lot of activities in the educational sector. There are lots of different groups and there are lots of very active, both individuals and groups. And you've already heard from a number of them. I saw Sivuyilis talk yesterday on the program, and I saw that there's going to be a parallel session where Carl Pennypacker and others are going to tell you about various programs. And there's such a lot out there. So NASA, GTTP. So why an office? So first of all, the office is, again, as was the case with the OAO that Lina just told us about, an office of the International Astronomical Union. We are a sister office to both the OAO that Lina just talked about and the OAD. So Kevin was of course there on the first day for the opening. We are very new. We are the latest in the office family. We were founded just in December 2019. So we commenced activities just in time for the COVID crisis. So this office has never known another world than this one in pandemic mode. and it is meant to complement and support the many ongoing initiatives that leverage astronomy for education. So there's so many individuals, as I said, out there, so many groups out there who are organizing teacher trainings, who are organizing support actions, and also at the broadest level, who are teachers, educators, who are working directly with children, students of all ages. And I should mention that we are concerned not with university level education, we are concerned with primary and secondary school education. And our focus is on those things where we think that a broad international perspective can really be helpful to the local and regional activities. Namely, we concentrate on infrastructure, on professionalization, on translations in collaboration with the OAO Astronomy Translation Network, on having a fundamental pool of resources, and on the question of standards. So let me go into a little bit more detail there. So our target groups are basically two kinds of people. First of all, and that is the core of any educational endeavors, there are of course the teachers. They are the ones who are in contact directly with the students. They are the ones who are in the formal educational structures. And what we want to support is anything that helps teachers get access to high quality resources. Could be ideas for activities, could be something like a diagram or an astrophotograph. There's also the matter of training. This is something that for us is still in the future, not least because of the current pandemic, namely organizing and supporting regional and international schools for astronomy education. And as I already mentioned, one thing that is very central for us is then defining standards for resources and training events. So going around the community and finding a consensus on what are the quality standards that a teacher training event should meet, what are the quality standards that make for a good astronomy education resource. Then, of course, since we are anchored in the IAU as the Organization of Professional Astronomers, which is, of course, mostly research astronomers, although a number of them are interested in education and outreach, our second target group for professionalization is the community of astronomers who are active in astronomy education. And if you train as an astronomer, then it is not standard, or it's not by default, that you also get trained in education techniques. So that is not part of the standard career of a professional astronomer. So here we see our role in providing support for helping astronomers gain professional knowledge in education, knowledge about modern teaching methods, about evaluation techniques, and of course then also very specifically about the educational aspects of the various topics in astronomy and astrophysics, where there is a body of knowledge that gives you valuable clues as to how to teach these topics. And some of them are very complex, as we know. Think about cosmology and the misunderstandings in students' mind that can arise regarding cosmology. So that is another big area. And again, establish standards, disseminate best practice examples, connections between astronomy research, astronomy education research, and the teaching communities. Those are all important parts of our mission. So what are we going to do to reach that goal, or what are we doing currently to reach that goal? First of all, as I said, it's about infrastructure. So there is a lot of good material out there, but it is not always easy to find the resources that you need. So one issue where we are currently pushing very hard is to create an educational material database where hopefully eventually teachers will find educational material in the different forms and shapes, again, from simple diagrams and images to the description of activities. This includes also projects like AstroEDU. AstroEDU has been there long before the OAE, but we will now support that platform. That is a platform for peer-reviewed material on educational activities in astronomy. And in a similar situation is the Big Ideas in Astronomy project, again, something that started long before the OAE, but that we've now taken to supporting, which is the idea of trying to define what is astronomy literacy as a guideline and framework, both for outreach and educational activities. Then there's the matter of creating and curating and disseminating resources. Again, curating has an important role since there's so much in terms of resource and material already out there. What we aim to create in addition to that are what we call the OAE reviews. So we all know that from science that a review article is something that summarizes in a structured way the research that has been going on before. So think about an OAE review as something very similar, namely as a quick and compact resource that tells you something in a very compact way, because all of us do not have time to dive into areas other than our own very deeply. So that tells you something that you as an astronomy education practitioner need to know. It could be something on a key topic like equity and inclusion. It could be something more specific like daytime observations with school students. So think about these OAE reviews as living documents that help those who are interested in astronomy education to get quickly up to scratch in the diverse sub-facets of the field. Then there's the question of fundamental astronomy education resources. And this is very strongly tied to translation, because we all know that in an educational setting, it is, it is important for teachers and students to have material in their language, just to remove the extra barrier that teaching in another language would entail. So there's lots of resources, of course, in languages like English or French, and our goal is to have at least a selected fundamental set of resources that are available in as many regional languages as we can manage as well. Again, one project there is a multilingual glossary, another collaboration project with the Office for Astronomy Outreach, which is meant to help with faithful translations by giving you the basic terms of astronomy in many different languages in an authorized, that means checked by professionals, in this case, translation. So there are also some other systematic activities. One is that we intend to create an overview of how astronomy education works in all the different countries of the world. That is something that is currently ongoing. And also there's a broader goal of promoting astronomy in national and regional curricula. Okay, so who is the we that I've been talking about? First of all, it's the Office of Astronomy Education at Haus der Astronomie in Heidelberg. I'm speaking to you from Heidelberg in Germany right now. We are a center for astronomy education and outreach, and we were selected in a competitive process by the IEU to host the Office of Astronomy, the Office of Astronomy for Education. I misspelled it there. Then, of course, since this is a very ambitious and international endeavors, we are aiming to create support in other countries. So we are very pleased to be able to say that we just signed a memorandum of understanding with an OAE center in Italy that is going to be part of the OAE network. And then similar to what you already heard from Lina, where they have a network of national outreach coordinators, we have a network of national astronomy education coordinators who are the liaison to their local and regional communities. And then, of course, with us as well, there are plenty of slots for collaborators. For instance, each OAE review will have an OAE review panel of experts contributing. So that is again, a lot of structure, most of it volunteer-based, some paid positions that are behind this endeavor by the IEU. And here down there, there's sort of a symbolic picture for that structure. That is the founding of the OAE in Paris in December 2019. And you can already see a number of the people involved. So one call that is involved here is that we are still looking for additional national astronomy education coordinators. This is our current map, and you can see that, to our great shame, we have not managed to find coordinators in a number of countries on the African continent. So please, if you want to do a single thing today to support the Office of Astronomy for Education, have a look at that map. And if you see a country in gray where you know somebody who's interested in astronomy education and who might be a good person to be part of such a team of liaison work with the OAE, then please contact them, contact us, and let us see that we can get those gray areas filled out and really connect to all the parts of the world. And that concludes my brief presentation. So if you want to know more, this is here you have sort of some of the community, notably the NIACs and some of the other contacts. You have also our social media data. We are on Twitter. We have a website, of course, where there's lots of more information. We are on Facebook. So this again is something where we are all of us in this together. It's a great collaborative effort carried by many individuals. So again, if you want to be a part of this, if you know somebody who might be a good NIAC in one of the countries where we are still in search of NIACs, then please contact us. And yeah, thank you for your attention.
Thanks very much, Marcus. As a member of AfAS and the chair of the science committee, but also on the executive, it, I think, behoves the society to assist you in the task at hand to try and connect and find connections in the rest of Africa. And I'm sure my colleague Niroj would be very much of the same opinion. So I think this is something we would like to see happen. We have one question in the chat from AfAS-2021. Is the OAE also involved in cultural heritage aspects and historical archival facets of astronomy?
That is not part of our mission. I know that there's overlap, for instance, with what the commission, what the relevant commission within the IAU does. There is sort of a heritage aspect there, but we are quite narrowly focused on primary and secondary school education. And even without additional aspects, we do have our work cut out for us.
Yeah, and there are commissions, I think, within the IAU which support that type of activity.
Yeah.
Okay, since we're running about 5 minutes behind time, I'd like to thank all of the speakers in this first plenary of today. We'll have a short break, about 10 minutes before we resume at 10:45 for the parallel sessions. So thanks very much and see you shortly.